Welcome to Geometry, Unit 9, Section 2. Measuring angles and arcs. Why would you want to measure one of those bad guys in the Lord of the Rings? Oh, wait, not arcs, not orcs. Oh, yeah, I get it now. Okay. Okay, angles and arcs. A central angle of a circle is an angle with a vertex in the center of the circle. Now recall that a degree is 1/360th of the circular rotation about a point. So here in this picture, we have this angle ABC, and it's a central angle of circle B because B has the vertex of the angle, but it's also the center of the circle. Okay, so the sum of the central angles, the sum of the measures of the central angles of a circle with no common interior points in common is 360 degrees. So in this figure, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 360. All right, let's find measures of central angle. So here we want to find the value of x. Well, I have three angles that share no common interiors. So I can look at this drawing and I can pretty much say the measure of angle F here is 90, right? So I can know that x plus 90 plus 130 is equal to 360. So x plus 220, right, 90 plus 30 is equal to 360. So I'm going to subtract 220 from each side, and I'm going to find that x is equal to 140. And there we're done with that problem, at least. Okay, find the value of x. What is the measure of angle QTR? So we don't know this angle QTR here, so I'm going to call that y. Okay, and we're going to go ahead and figure this out. Now, I can't go all the way around because I have a different variable here. What I can do is do some thinking and go, hey, look, I've got this distance, which is halfway around, right? So that's 180 degrees. So I can do my figuring from there. 8x minus 4 plus 13x minus 3 plus 5x plus 5 equals 180. So 8 plus 13 is 21 plus 5 is 26x. Minus 4 minus 3 is negative 7 plus 5 is minus 2 equals 180. So now we're going to go ahead and add 2 to each side of this equation. I've got 26x is equal to 182. So we divide each side by 26. And I get 182 divided by 26, and that is 7. Okay, so if that's equal to 7, then this angle right here is going to be 140 degrees, right? And since that's 140 degrees, this section right here where we have y, the measure of, so angle QTR would then have to be 40 degrees. Okay, a minor arc is the shortest arc connecting two endpoints on a circle. So the measure of a minor arc is less than 180 and equal to the measure of its related central angle. So in this case, the measure of arc AB would equal to the measure of angle ACB, which is x degrees for this diagram. Okay, this would be a minor arc. Okay, a major arc is the longest arc connecting two endpoints on a circle. So the major arc must be more than 180 and the equivalent of 360 minus the measure of the minor arc with the same endpoints. When we name a major arc, we use 3 points. Okay, so in this case, this red section of the circle, the measure of arc A to D to B is equal to 360 minus the measure of arc AB, and that's equal to 360 minus x. This would be a major arc. Okay, a semicircle is an arc with endpoints that lie on the diameter. So the measure of a semicircle is always 180. It's halfway around the circle. So if the whole way around is 360, halfway around is 180. Okay, let's classify some arcs and find some arc measure samples. Examples, I should say. All right, so segment GJ is a diameter of circle K. Identify each arc as a major arc, minor arc, or semicircle, then find its measure. So the measure of GH, well, that's pretty easy. So that would be equal to 122. Now, this arc is a minor arc. And it's less than 180. GLH, that's this one. So, and when you name these, you go from G to L to H all the way around here. Well, that's going to equal 360 minus 122. So you might want to take out a calculator here. Do 360 minus 122, and you come up with 238. And this would be a major arc. Arc GLJ, which would be from here, and it would stop right here. So, and since it does that, that is a semicircle, right? So that's equal to 180, and that is a semicircle. Okay, so in the same circle or in congruent circles, two minor arcs are congruent if and only if their central angles are congruent. So in this drawing, if angle 1 is congruent to angle 2, then arc FG is congruent to arc HJ, excuse me. And if we give you the information that if arc FG is congruent to arc HJ, then we can deduce that angle 1 is congruent to angle 2. Okay, let's find arc measures in circle graphs. All right, refer to the circle graph, find each measure. So the measure of CD, well, C goes to D. That's from here to here, and that's the volleyball section, and that measures 18%. So what we would do is we would multiply 18% times 360, because we're looking for the number of degrees. So I would multiply 360 times 0.18, and I get 64.8 degrees. So the measure of arc CD is 64.8. BC, well, that has the same percentage, so guess what? I don't even have to do any work, 64.8 degrees. Okay, adjacent arcs. So those are arcs in a circle that have exactly one point in common. So in this case, these arcs only have point J in common. Okay, so they would be said that those arcs are adjacent. Okay, so the measure of arc XYZ, which would be from here to here, right, is going to equal this arc plus this one. And you might look at that and think that is some common sense, no kidding. But you'd be surprised. Okay, let's use arc addition to find some measures of arcs. Okay, arc AED. Well, I can take 63, right, and add, so that would be adding this one plus this one here. So that's equal to 90 plus 63, right? And that's going to come out to 153. Now, arc ADB. So I'm coming all the way around here, ADB. Well, if you remember this has been a while, this angle here is going to be congruent to this one here, right? So I know that this one is 63. I can also look at this and look at this arc right here. This one I know that's pretty easy, and that's 180. So I can say 180 plus 63, and that is 243. Okay, arc length is the distance between the endpoints along an arc measured in linear units. Since an arc is a portion of a circle, its length is a fraction of the circumference. So the ratio of the length of an arc L to the circumference of the circle is equal to the ratio of the degree of measurement of the arc to 360. So you'll notice we have 2 pi r, right? 2 times pi times the radius, that is the measure, how we find a circumference, right? So find the length of YZ in each one of these, okay? So the first thing I'm going to do is so YZ is equal to 75 divided by 360 times 2 times pi times the radius, which is 4. So I'm going to put that all in the calculator. And I'm going to use my fraction bar here, and I'm going to say 75, not by 36, by 360. 75 divided by 360, and then I'm going to multiply that times 2 times pi times the radius, which is 4, and I get 5.235987756. Nearest 100th, that's going to be 5.24, approximately 5.24. Okay, again, YZ, that is 130 there, right? Same process. YZ is equal to 130 over 360 times 2 pi r. Well, in this case, I'm given a diameter of 10, so I could just say 10 pi, right? Because pi times the diameter is the circumference. So this is going to equal, we're going to use our calculator, 130 over 360, and multiply that times 10 pi. I got 11.3446, so it's 11.34. Over here, it's the same problem as we started, but instead, this time, YZ is equal, the radius is 6. All right, so YZ is equal to 75 over 360 times 2, pi times 6. Done plugging that in. I got 7.85. Okay, this one here. Find the length of DA. So this will be, again, DA is going to equal 40 over 360 times 2 times pi times 4.5. We're going to keep setting this up the same exact way. So, fraction bar in there. 40 over 360 times 2 times pi times 4.5. And it's 3.1415, blah, 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 blah. So it'd be 3.14 for this problem. Interestingly enough, when I take this and simplify it all, it's actually equal to pi. Okay, all right, here we have a diameter now, right? So still we're working on AD. Now this is 28. So 180 minus 28 is 152. So on this one, DA is equal to 152 over 360 times pi, 12 times pi, right? Because 12 is the diameter. So again, we set this up. And I got it, let's see here. Okay, let's try this here. There we go. Having some issues. 152 divided by 360 times 12 pi. I got 15.91 7, which becomes 15.92. All right, AD, again, pretty simple problem. dA equals 140 over 360 times 2 pi times 6. So 140 again. Divided by 360. And then we're going to multiply that by 2 times pi times 6. I got 14.66.